Okay, this is a video about interpreting marginal cost. So what does marginal cost mean? First of all of this works with marginal revenue as well. So you can do the exact same thing with marginal revenue. All of the analogous statements hold. Okay, so let's do this by example. Let's suppose that C of Q is the cost in dollars of producing Q items, whatever they may be, and we're given the following information. We know that the marginal cost is 3 when Q equals 100. So remember, marginal cost is the same as the derivative, so we could view this as being the same as C prime of 100 equals 3. Equals 3. So there's a couple different ways that we can look at this. We can say that, well, if the marginal cost is 3 when Q equals 100, this is how much the cost is changing in dollars per item. Remember, the units of the derivative are the units of the vertical axis, which in this case is dollars, over the units on the x-axis, which in this case is items, how many items we're producing. So in other words, the units of the derivative are in dollars per item, so we could say that the derivative is $3 per item when Q equals 100. So one way to view this is that this 3 right here is the cost of producing the next item. So the cost of the next item, and which item is that? Well, that's the 101st item because we're at Q equals 100. So the cost of producing the 101st item. Okay, and another way that we could look at this, another way in which this is useful, is suppose that we knew what the cost was then. Suppose we don't know what the cost of producing 101 items is, but we know what C of 100 is, for example. Suppose that the cost of producing 100 items is, say, $80. So what then does this tell us? If we want to know what the total cost of producing, say, 101 items, we can approximate this. This won't be exact, but we can say that this is roughly speaking, or I should say approximately, rather. This is approximately the cost of producing 100, which is $80, plus the cost of the 101st, which is $3 in this case, 3. So this is $83. So it's useful for a few things. We know what the cost of producing the next item is, and if we know what the cost is at that same point, we can interpret the total cost. We can interpret this as an approximation of the total cost. For that matter, we can go backwards with this as well. We could find out what C of 99 is. And what is C of 99 in this case? I guess we can't find out exactly what it is. Again, this is an approximation. But C of 99 is roughly C of 100, which is 80. And then in this case, we subtract the 3 because we're going backwards. So this would be $77. $77. Okay, these two things are both these are both applications of what is called local linear approximation. This was from section 2.3. For those of you who are curious. And that concludes this video.